Hello friends. In today's session on data handling, we'll be talking about the arrangement of data and the different terms related to it. So let's first see how do we represent data. Now data can be represented graphically in the form of pictographs, bar graphs, double bar graphs, pie graphs, line graphs, histograms, etc. And we've talked about all of these in a different session. Data can also be represented in non-graphical form. So all of these, the pictographs, bar graphs, etc., are the graphical representation of data, but we can also represent data non-graphically in the form of tables, in the form of arranging them in ascending and descending orders, by grouping them together, and so on. So we'll be talking about the non-graphical method of arranging data in this session. So this is just an example of how do we put the data in the tabular form. So now let's talk about arranging data. So the raw data can be arranged in ascending or descending order to form an array. So supposing we have any data, now we'll just take an example of any a few numbers we can take. We'll take some data like this. So we have these 6 numbers. Now if we put them either in the ascending format, ascending order would be like 2, 3, 5, 6, 8 and 9. So we could either put it in ascending order or we could again put it in the descending order. Now this form of arranging the data gives you an array. So now if this kind of arrangement of data is possible for a small set of numbers. Now in this array or in any set of data, the difference between the greatest and the least value in the data is called the range of the data. So if we talk about this set of data that we had, we know that the smallest number is 6 and the greatest is 9. So the range of this data becomes 9 minus 2, which is 7. So difference between the greatest and the least value in the data is the range. Now if the data set is spread over a wide range and has too many elements, so if it's just a small set of 6 elements, 10 elements, it's fine. But if we have a bigger data of say 50, 100 entries, then arranging them in ascending and descending order is just one way, but that's not very handy. It's not very easy to use that kind of a data. So in those cases where we have bigger data, we try to put them into groups and we find out its frequency corresponding to each group. Now first of all, what do we mean by frequency? Frequency is like in this set of data that we've made here, we have every number only once. Now supposing I add this another 2 to this, or maybe another 6 to it. So if I increase this data, 2 and 6 added to this, now I can say that I have 2 appearing 2 times, I have 6 also appearing 2 times. So now this is called the frequency of the data. So each of the data 2 and 6 is appearing 2 times. So the frequency of data 2 is also 2 and the frequency of data 6 is also 2. So this is what is called frequency. Now if we put this data into groups and along with that we put the frequency along with it, this is called the grouped frequency distribution, and we'll see how do we do that. So friends, let's now understand what do we mean by grouped frequency distribution. We'll take an example to understand it better. First of all, the groups and or classes in which the data is represented are called class intervals. So if we take the example that we took in the previous case where we were arranging the data that we had was 2, 3, 6, 5, 8, 9, 2, 6. Now instead of simply arranging it in ascending or descending order, if we make groups and specify the frequency. So for example, if we make a group of 2 to 4 and say that the frequency of 2 to 4 is 3, because we have 2, 3 and another 2 appearing in this range. So the another group that we can form is 5 to 7, where we have 6, 5 and another 6. So the frequency is again 3. And the last group that we make is from 8 to 10, and we say the frequency is 2 because we only have 2 data in this range, which is 8 and 9. So this is kind of group we can make along with the frequency. So this is grouped frequency distribution. In this case, the group that we've made, which are also called classes, 2 to 4, 5 to 7, these are called class intervals. So now we'll take another example for that. Say for example, we note down the weight of some children in the class and we make a grouped frequency distribution for that. So the class intervals that we make is 40 to 50. We know that the weight of the children in a particular class range between 40 to 70. So we say 40 to 50 is one class, 50 to 60 is another class, and we have 60 to 70 as another class. And we say that in the range of 40 to 50, we have 17 students. In the range of 50 to 60, we have 9 students. And in the range of 60 to 70, we have 6 students. So this is the frequency and this is the class that we've made. And now this frequency that we've written here can also be represented in the form of tally marks. What are tally marks? We represent this number, the frequency, using some bars. So the method of putting on the bars is we put 1, 2, 3, 4 bars till the number is 4, and for the fifth one we put a bar like this on these 4, and then we have another 4 and this. So we have 10 here, 15 and 2 more. So this is how we make the tally mark. For 9 we'll again make it like this, 5 and 4. For 6 we'll again make like this. So this is how we put the tally mark. So this is the grouped frequency distribution table where we make the class and we specify the frequency along with each class. The tally is always an optional thing. If it may be required, it may not be required, because if the number in the frequency table is huge, till 17 it is still possible, but if the frequency is of the range of 50 to 100 or something like that, making the tally using tally marks using these bars is not very advisable. Now each class interval, as we know, this is 40 to 50 is one class interval, 50 to 60 is another class interval, 60 to 70 is another class interval. Each of these class intervals are bound by two figures. In this case 40 is one and 50 is another. So which are called the lower class limit, which is 40 in this case, and upper class limit, which is 50 in this case. So for this group, For this class interval that we are talking, 40 is the lower class limit and 50 is the upper class limit that we have. And the difference between the two, between 40 and 50, that difference is called the width of the class interval, which is 10 in this case. So width or size of this class is 10. Now the mid value of the class interval, which is 40 plus 50 by 2. So midpoint of any two numbers, mid value of any two numbers can be found by adding the two and adding the two numbers and dividing them by 2, which gives us 45 in this case. This is called the class mark of the class interval. The frequency corresponding to the class interval is called its class frequency. So if you're talking about the 40 to 50 class interval, the frequency is 17. So frequency is specific to each class interval is given in this table. Now let's understand the different types of class intervals. We have two ways of writing class intervals. One is the exclusive form and other is the inclusive form. So we'll talk about the inclusive form a little while from now. Let's first understand what is the exclusive form of class interval. The upper limit of one class coincides with the lower limit of the next class. We are saying 0 to 10 and the next class is 10 to 20 and the next is 20 to 30. So these two, the upper of the first and lower of the next, are coinciding, and similarly this upper of this one and the lower of the next one is coinciding. So this type of class interval is called exclusive form of class interval. In this case, now since this 10 is appearing in both of these, it is not possible that we include them in both the class intervals. Then we'll have incorrect data, because supposing we have a data of 10 and we put them in both, that means the total number of data will show up to be more than the actual data, which we don't want. So we include the lower class limit in the class while the upper class limit is excluded. So we are saying 0 and 10. 0 will be included in this and 10 will be excluded from this. 10 to 20, 10 will be included in this, 20 will be excluded in this. So the lower class limit is included in the class and the upper class limit is excluded from the class, and this type of class interval is called the exclusive form of class interval. So 0 to 10 class interval means 0 to basically less than 10 and then 10 to less than 20 and so on. The next one is the inclusive form. In inclusive form, both the lower and the upper class limits are included in the class. As I talked about the previous example where I was making the classes of the type 2 to 4 and then I made 5 to 6, 5 to 7. I did that specifically because I did not want to, at that point I did not want to repeat anything. So here we are saying this kind of a thing is called the inclusive form, where both the lower and the upper class limits are included in the class. So in that case we'll not have a class of the type 0 to 10 and 10 to 20. We'll have 1 to 10, 11 to 20, 21 to 30 and so on. Or if we want to start from 0, then we'll have to make it 0 to 9 and then we say 10 to 19, 20 to 29 and so on, because both the lower and the upper are included in the class, so we don't want any repetitions here. Now let's see how do we convert from inclusive form of class interval to the exclusive form of class interval. Now before we start with that, we'll first want to understand why do we need to do that. If we are given the inclusive form of class interval, that should be fine, and exclusive should also be fine. Why do we want to convert? Now the main reason why we want to do that is because when we plot the histograms that we've talked about, we have histograms which are adjoining, like this. We have 0, 10, 20, 30 and so on. So we have class histogram shown like this. Now in this, to have it like this, we'll have to convert the inclusive form of class interval to exclusive form of class interval. Now this is what we do to do that. We first take half of the difference between the upper class limit of a class and lower class limit of the next class. So we are saying if we have a class from 1 to 10 and then we have 11 to 20. So we take the difference of this, the upper of the next minus the lower of the first, and then take half of that difference. So we have 11 minus 10 by 2, which gives us 0.5. Now this is now subtracted from the lower class limit of every class. So we are saying instead of 1, we'll subtract 0.5 from this and it becomes 0.5 to something. Then the next becomes 11 minus 0.5, which is 10.5 to something, and so on. And what is this something? We add this difference 0.5 to the upper class limit. So we make it 10 plus 0.5. So we have 10.5 and here we'll have 20.5 and so on. So this is how we get the conversion done, and then we make the new classes in the exclusive form. So as we just discussed, we get this 0.5 and then we subtract from the lower and add to the upper and we get the classes of this type. Now this is very important to understand that this is required specifically for plotting histograms. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.